Hey everyone, welcome to another episode of Phillip in the Cloud. Today we're talking about how you can run arbitrary Python code on Snowflake using Ibis. Um, so let's get started. Today we're going to first do some imports. We're going to then import the OS module. We're going to connect to Snowflake, and then we're going to pull out the batting table. And we'll just take a quick look at that to see what's in there. Cool, we've got player ID, year ID, stint, team ID, and a couple of other things. If you've been following along, you'll notice there's a little change in the output of the table. Now we're showing string data in green, and we've made some other improvements to the output. Check that out at ibis-project.org. Also like and subscribe. That would be great. And let's talk a little bit about UDFs. UDF is a user-defined function, and it's a way that you can kind of take code that may not exist in your upstream backend, in this case Snowflake, and run it, define it in your terminal session or your pipeline or wherever you happen to be using Ibis, and you can run that code kind of natively on Snowflake. And Snowflake actually has pretty good support for UDFs. You can kind of define, there's two different kinds of UDFs. You can run kind of element at a time, or they have a batch API. We don't support that yet in Ibis, but that is something we plan to support. And so Snowflake actually does have pretty good upstream support for defining UDFs. I should say that I'm operating off of a branch from a PR, so maybe don't use this in production yet. Um, there's still code review that has to be done and other things to kind of get this done and upstream into a release. But that said, I did want to show everyone like a feature preview to give an idea of what this looked like. If people have strong opinions, please get involved. It's open source. We like when users get involved and give us feedback. So to that end, let's get started. let's say I wanted to figure out what the count of vowels was in each of these player ID names. There isn't like there's probably a way to do this like with SQL, but I know how to like fairly concisely express this in Python, and so I just want to define that in Python. So in the current sort of experimental provisional API, we have this udf.scalar, which says I'm going to define a user-defined function. I'm going to say .scalar, which means for every element in, I'm going to get an element out. And that means if I give it just a single row's value, I'm going to get back a single value. And if I give it a column, it's going to run this function on every element in a particular column or columns, depending on how many arguments there are. Start with that. And we're just going to call this numVals. And you can see IPython is kind of blowing up my spot and giving everything away. But that's fine. So it's going to take a string and it's going to count the number of vowels in that string. And so the way we can do that is we can say sum, and then we want to run the string count method on every value in this string constant, which lists all the values A, E, I, O, and U. And there it is. That's your UDF definition. And so the next thing you want to do is kind of run that in an Ibis expression, right? So let's just try and run that on the player ID column. You can just call it like a function, and you can say batting dot player ID. Hopefully this works. Kind of flying by the seat of pants here. Let's see what happens. Cool. Let's verify that by projecting it out. Let's say, batting dot select, and we'll say we'll use underscore to make life a little more convenient. You can't yet use underscore with UDFs. We may or may not support that. But I haven't actually looked into it yet. So let's look at that. And we can see that I don't know exactly what the name here is, but we can see that this string has A in it, E in it, and another A. So it's got 3 vowels. So we're actually counting the same vowel twice, That's fine. I just want to know how many vowels there are in the string. If you wanted to count the distinct values, we implement that in a different way. Of course, this is a scalar function, so you can use it anywhere else you'd use a scalar function. Like let's say we wanted to count the counts of vowels in every string. So we might say batting.group by num vowels, and we'll say we'll call our function num vowels, and we'll call it on batting.player ID. We'll say .ag, and we'll say n equals underscore dot count, and that's for every count of vowels. That's going to give the number of rows that correspond to that count. So let's see what that does. Cool. So now there are 53 names in there with 0 vowels, about 5,000 with 1, etc. And you can see this kind of makes sense, I think, with an intuition for English. Like many or most names have vowels. Many or most names don't have 5 values. They're somewhere in between 1 and 4, with the most being, with the sort of the center of the distribution being at 2 and 3. So that's pretty cool. What if I want to, let's say, return, let's say I want to include the letter Y in my vowels. So I'm going to redefine num vowels, and I'm going to call it num vowels Y. And I'm going to say include Y as a Boolean, okay? And I'm going to give it a default value of false. Now, it's important to note, I didn't say this earlier, but you have to give type annotations here. Otherwise, Ibis doesn't really know how to validate your function. So we sort of, for the user's benefit, for your benefit, we require these type annotations so that we can generate code that type checks kind of before you ever send your SQL string to the database. In this case, the type annotations are kind of plain old Python types, and we convert that into like Ibis's type system for you. So we want to include Y as well here. So we're going to modify our definition a bit. It's basically going to be the same, except that instead of just A, E, I, O, and U, we're also going to include Y. But that's not totally correct either. We actually only want to include Y if include Y is true, and it's by default false. So we're going to take advantage of the bizarre, cute multiply a string operator by an integer. And since bools are integers, we can do that. And we can say include Y. And so what this means is that if include Y is true, Y will be the single string Y. And if it's false, then that means 0. So it's going to repeat the string Y 0 times and be the empty string. And so then it won't be looped over in this loop. I'm just kind of doing this for being concise. You might not implement it this way so your coworkers don't hate your code. And then we can kind of do the same thing. We'll say num vowels Y here, and then let's say include Y equals true. And something got weird. Probably because I gave the argument to the wrong thing. Let's try that again. Okay, so now we actually have 1, 2, 3, 4, 5, and 6. So now all names have at least A, E, I, O, U, or Y in them. And if you considering Y, it looks like some names have 6 vowels if you include Y in there. So that's kind of an interesting result. And as always, like we probably want to see the SQL, and so we can see that here. And it's just a function call because we've defined it as a UDF in Snowflake. Snowflake makes that pretty straightforward, and it's just another SQL function ready to be called by your query. Let's say you want to do something a little bit more complicated. Let's say you want to produce a map where each key in the map is a vowel, and then each value in the map is a count of the number of that vowel in the player's name. This is going to be a little bit more complicated. It's a slightly more complicated problem. So let's kind of jump right into it. Again, it's going to be a scalar function. We're going to call this numVals map. I'm going to leave out the y bit for now just to keep things simple, or simple as they could be. And here we're actually going to return, we're going to tell Ibis the return type is a dictionary whose keys are string and whose values are integers. And then what we're going to do is we're going to make a vowels variable that's just A, E, I, O, U. Doesn't really matter what order it's in. We're going to initialize a counter using this somewhat rare in the wild method dict.fromKeys, which takes first argument as a sequence and then a value that gets put in there for every key. So in this case, it'll be A, E, I, O, U as keys, and then initialize with 0 in the values. We're going to loop over the string, and then we're going to say if the character in this string is in vowels, oops, right, then we're going to add 1 to that count for that character. And then we're going to go, and then we're not going to go anywhere. We're just going to return the counter. So for each string in a column, we're going to produce a map that's got A, E, I, O, and U, and the values are the number of those respective characters that are vowels in the string. So let's take a look at what that looks like. So we might, let's just like kind of project that out. Do something pretty simple. Select. Let's call it vowel dist, and we'll say numVowels map t.playerID. And let's add the player ID in just so that we can verify that the thing is actually correct. And we'll just call this expr in case we want to look at it again. Well, I don't have anything named T in scope, so that's my fault. And you'll notice again, like Ibis is returning instantly here, and that's because I gave it the type annotations, which allows Ibis to actually infer those types and turn them into Ibis types and generate like correct SQL when you call this function. And we haven't actually executed anything yet, but we can like look at the SQL. Okay, it looks like I haven't defined a translation rule, so that's not great. That's probably a bug. Let's see if it actually executes. What's happening here is there's a bug in the implementation that the UDF actually isn't yet defined, and I haven't defined anything until we're about to execute the function. We probably need to move that to the compilation phase, which is what's called when show SQL is called. So that's actually a bug. Always good to find bugs. But now we can see that we actually got out vowel dist, player ID, etc. We can let's get the first 5 and then pull that out as like a pandas data frame so we can look a little bit deeper into that. All right. So cool. So last we saw that AB ABRSDA01. I don't actually know what player that is, but you can see there are 2 A's, 1 E, and then 0 of the rest of the vowels. And so that's kind of, you can use these UDFs in pretty powerful ways. You can use complex types, you can use primitive types, you can use regular Python code, and we're definitely looking into ways to support kind of more complex UDFs where that may sort of require dependencies or even use things like stored procedures. We've already had a user request this, and we're definitely interested in working kind of with Snowflake to get that done. So please get involved, like or subscribe the channel, ibis-project.org, and I will see everyone